Hello and welcome everyone to today's LeetCode challenge. And today's question is question number 2924. Find champion second. This is a graph question, and in graph basically this is a DAG, that means directed acyclic graph. The question states that there are total n teams numbered from 0 to n minus 1 in a tournament. Each team is also a node in a deck. We have given the integer n and a 0 index to the integer array that defines the edges of I, U, comma V. That means there is a directed edge from 0 towards V. A directed edge A towards B states that A is stronger than B, or vice versa, like B is weaker than team A, and team A will be the champion of the tournament if there is no team B that is stronger than this team A. And we have to return the champion of the tournament if the champion is unique, otherwise we have to return -1. So the nodes here are that the nodes numbers are represented in the range from 1 to n, and this is basically a non-cycle graph. That means, as the name states itself, DAG, directed acyclic graph. So let us look at the example number 1. We have given n equals to 3, that means there is only 3 nodes in this, and this 0, 1 states that there is a directed edge from 0 towards 1, and 1, 2 states that there is a directed edge from 1 towards 2. And who will be the champion for this tournament is basically the node that is stronger than amongst all the nodes. Now this, let us look at this 1, 2. This 1, 2 states that 1 is stronger than 2, so 2 will never be the champion of this tournament. So the answer could be 1, but let us visualize the other nodes as well. This 0, 1, this 0, 1 states that 0 is stronger than 1. Now 1 is stronger than 2 and 0 is stronger than 1 states that 0 is also stronger than this 2, and there is no node present in this graph that is stronger than this 0. So we have to return 0 in this case, and as the answer is unique in this case, that means there is no other team that is will be the champion of this tournament, so we have to return this. And let us look at this example number 2. We have given n equals to 4, and edge is given as 0, 2, 1, 3, and this 1, 2. Now 1, 3 states that this 1 is stronger than 3, so 3 will never be the champion of this tournament. 1, 2 states that 1 is stronger than 2, so 2 will never be the champion of this tournament. And this 0, 2 also states that 2 will never be the champion of the tournament. Now who will be the potential champion of this tournament are this 0 and this 1. Now there is no condition given to us to compare between these two values, that who will be the strongest among these two. And in this case we found out that there are more than one champion team in this tournament, and we have to return -1 in this case, as there are multiple answers possible in this case. So what will be the basic intuition to solve this problem? The basic intuition to solve this problem is the concept of in degree, as we can see here in example number 1. 2 is not a answer for this example number 1 because it have a in degree of 1. 1 is not an answer of this because it has in degree of 1, and this 0 is the answer because it have a in degree of 0. And here as well, the in degree of 3 is 1, in degree of 2 is 2. This 0 and 1 have in degree of both have in degree equals to 0, but as the answer is not unique in this case, so we have to return -1 in this case. So our basic intuition to solve this is just to find the nodes that have in degree equals to 0, and if our answer is unique, and that means if we find out a single node only that have in degree equals to 0, then that will be our answer of this question. Or if we find out that more than one teams are possible, or more than one teams will be the potential champion of this tournament, so we have to return -1 in that case. So let us code this, and let us look how this will be solved. So first define our array for n degrees, and now move on edges, and n degrees basically the incoming node. That means 0 comma 1 means we have an incoming node on 1, so we only required v in this case, and to find out this u is basically redundant. V equals to edge of 1, in degree of v is plus plus. That means in degree of 1 is now 1, in degree of 2 is now 1, but the in degree of 0 is initially 0. So let us now find out that whether the in degrees or whether the unique team for this DAG exists or not. We can check out this from find out how many nodes in this in degree array have in degrees greater than or equals to 0. Basically we have to find out that how many nodes in this in degree array have in degrees equals to 0. So traverse on this in degree array, check if in degree is equals to 0, and if in degree is equals to 0, we have to increment our counter and save our current answer in this ANS, and finally check if there is only a unique answer, or that means there is only a single team that has in degree equals to 0. If this is, we have to return our ANS. If it is not, then we have to return -1. Let us run this. It is running fine. Let us submit this and check. It is running fine, and it is absolutely a very easy and simple concept to learn. And this is basically the shorter form of topological sort. We can also use topological sort to solve this question, but to use topological sort will basically lead to us to increase the space complexity of too big of n. That means we have to store the topological order in a vector. And that is basically redundant for us, because storing the topological sort and then check if that array or array list has a size is equals to 1. If it is equals to 1, then we have to return the first element, or if it is greater than equals to 1, then we have to return -1. That means there are basically 2 or more nodes that have in degree equals to 0. So thank you so much guys for today's lecture. Thank you.